Hello everyone, welcome to EFS. This is project number 3, IoT display. As you can see, we will be sending a message from our mobile app and then that would be displayed on our LCD display. See? So after that, we're going to send a second message and it's going to display just below that. Okay. So this is EFS and I'm sending it. Boom. Okay. So along with that, we have made a scrolling effect as well. So now what we're going to do is that we're going to just type a longer message, and once we click on send, this is going to scroll. So before getting into the coding section, let's just try to understand what we're actually trying to do. Okay. So the idea of this project is pretty simple. So we'll be having a mobile app. Let's just say this is mobile app. Okay. So we're gonna connect it with an MQTT server, the Hive MQ which we used in the last project. So let's just say Hive MQ here. So this is the MQTT server. Okay. And along with that, we'll be having a NodeMCU, which will act as the receiver, NodeMCU. But as you know, NodeMCU doesn't have the capability to run an LCD display. So we will be using an Arduino as well. So say this one is the Arduino. Okay. And finally, we have the LCD display, which would be something here. So we are using a 16 by 2 LCD display. That means it has 16 columns and 2 rows. So it can print up to 32 characters. And since it has a scrolling effect, we can, whenever it exceeds the specific length of like the 16 characters, then we can start the scrolling effect. So how does this function, like how does this design completely work? So what's going to happen is that firstly, let me just take an arrow. So firstly, we're going to send, we're going to publish, since we're using the MQTT server, the publish means sending a message, subscribing means receiving the message, not specifically receiving the message. So when you subscribe to a topic and you will be continuously listening to that topic. Okay. So whenever there is a message in that topic, then you will be subscribing to that. I mean, you will be taking that message. Okay. So here we're going to connect to the MQTT server and then we're going to publish our message to the Hive MQTT server. So then what's going to happen, the NodeMCU, which is, so when you're publishing as well, you're going to publish to a certain topic. Okay, let me just write it about topic. Okay, so the topic and publish will go to the MQTT server, and the MQTT server will kind of, we have different quality of services. So it's going to send whatever, like a trigger to the NodeMCU. So whenever the trigger happens, the NodeMCU continuously waits for that specific trigger. And when that happens, the NodeMCU is going to subscribe to that specific message which appeared in that topic. So here I'm going to type subscribe. I'm not talking about the YouTube subscribe, the subscribe. Okay, spelling mistake. So after that, what's the NodeMCU gonna do? So it's gonna send this specific data to Arduino. It's gonna pass the string to Arduino using serial communication. So let's take another arrow. So using serial communication. Okay. Then since we are connected to, like, I'm gonna show you the entire circuit design. So we're not using any kind of I2C bus or anything like that. We're directly connecting it to the Arduino to the digital pins. So now Arduino is gonna send this data to the LCD display. Okay. So that's what we're trying to do. So this is what we're going to actually do. Okay. So we're going to take a mobile app. We're going to create the Flutter mobile app, and then we're going to publish a message within with a topic, and then it's going to go to the MQTT server, and then the NodeMCU will subscribe to that specific topic. And whenever there is a message in that topic, the NodeMCU will take that message and then it will be sent it to Arduino using serial communication, which I forgot to write. So here it will be serial communication. Okay. And finally, Arduino will display that specific text in the LCD display. Okay. So that's what we're going to do. So let me show you the circuit diagram. So here, like, you'll be understanding them. So if you can go through any of the tutorials that's available in the net, you'll be understanding these connections. So as you can see, we are not using any voltage divider over in this connection because we are not expecting anything returned from the Arduino. Okay, so as you can see, I have only used the RX pin, not the TX pin. So what's going to happen? This NodeMCU's TX is going to go to the Arduino's RX. So since we are sending the data and we are not receiving the data, so there is no need to use any kind of voltage regulators. Okay, and here we have different set of pins, like this is the ground pin, this is the supply pin, this is the V0 pin, and this is used to control the contrast of the display. So like how much visibility is there. I mean, for different scenarios, you'll be requiring different contrast adjustments. So whenever you turn this knob, depending on the direction, the contrast gets adjusted. And along with that, we have a VCC pin which goes to this. I mean, this is an RS pin, sorry. And then we have which is register select. And along with that, we have RW pin, enable pin, read write pin, enable pin, and along with that D4, D5, D6, D7, and finally LED plus and LED minus. Okay, you can just go through this entire schematic. Okay, so now let's just get into the coding part. So let's get into the first step, that is writing the Arduino code. So using Arduino, we're gonna control the LCD display. So for that, we're gonna use a library called liquidcrystal.h. Okay, so this is a library that kind of handles everything like the register selection and everything. And only we have to use certain predefined commands so that the words can be displayed on the LCD. Okay, along with that, I'm gonna use another library called software serial. So I'm not gonna use the native RX and TX pin. So I'm gonna use the software serial library and declare two digital pins as TX and RX. So this will help me to upload the program frequently. If there are any pins on the RX and TX, native RX and TX pins, then we cannot upload the program. We have to remove them. So for that purpose, I'm gonna use the software serial.h library. So here we have to define a class of the software serial. So this is hardware, it's a subclass of hardware serial. So this is a software serial. Along with that, we're gonna give it a variable my serial and two pins, which is 8, 9. So the first one will be the RX pin and the second one will be the TX pin. Okay, so then now we're gonna start the serial baud rate, serial.begin, and I'm gonna give 1,15,200. And along with that, we have to start the my serial as well, the software serial as well. So for that, we're gonna do the same. We're gonna say 115200. Okay, so after that, we have to define like what is the LCD type. So we have multiple different types of LCDs. So for that purpose, we have to define the LCD type. So before that, so in general, different people have different process. So I usually like to declare the pins so that I can change them later on. So RS pin, okay, 12, comma EN equals to 11, comma, which is enable. RS means register select, EN is enable, and then we have the digital data pins D4, comma, and then we have D5. So we're gonna use the pins 5432 for that, and then we have D6 equals to 3, and then we have D7 equals to 2. Okay, so now we're gonna tell the liquid crystal display library that these are the pins that we have connected to the specific data points. So for that liquid crystal, then we're going to create the variable LCD, and then we're going to define the pins in the same order: RS, comma, EN, comma, D4, comma, D5, comma, D6, comma, D7. Okay. And after that, here we're going to tell what kind of a display that we have. Different type of displays, like we have 16 cross 2, we have 32, 16 cross 4, and a lot of other displays. We are using 16 cross 2, so I'm gonna say 16 comma 2. So what is this? 16 comma 2, 16 columns and 2 rows. That's what this is. So we are done with the setup part. Now we're gonna go to the loop part, the main program. So since we're gonna receive the data from serial, which is here in this case is my serial, so we're gonna check whether there is any data on the serial port or not. So I'm gonna say available, my serial dot available is greater than 0. See, so now we'll check whether, like, if the data is there, only at that point this loop's gonna run, or else it won't. Okay, so after that we're gonna say string s equal to my serial dot read string until new line. So I'm gonna tell you why I have used the read string until instead of using read string. Once we create the app, once we create a connection between the NodeMCU and this, you will understand why I've done that. For the time being, just leave it as it is. So now then we're gonna say serial dot println, and then we're gonna print this as, just to see like whether we're getting the data or not. And after that, we're gonna create few variables. So the first one will be message count. Let's just call this message. Okay. Why did I declare it as an int? So this would be a string message. So we're gonna hold whatever message we got here inside this, and we're gonna say message equals to s. Okay, then what we're gonna do, once we get this, like, okay, now we have got the data. So what we're gonna do is that we're gonna go here. So we're gonna write everything out of the loop because it has to work continuously. So for that purpose, we're getting out of this loop. So lcd dot set cursor. So I'm gonna set the cursor at 1 comma 0, so which is first column, and this is the 0th row. Okay, so in general in electronics everything starts with 0. So if you have 16 columns, then that means 0 1 2 3 4 5 6 7 8 till 15. Okay, so in this means that it's gonna start a bit ahead, like it won't start at the starting pixel, but it's gonna start at the next pixel. Okay, so after that it's pretty simple: lcd dot print, and then what we want to print, message. That's it. Okay, nothing more than that. So here there is another logic, like if the message is too long, for each character occupies each pixel, but we have only 16 blocks. So if the character is more than 16, then we need to scroll it. So for that purpose, what we're gonna do, we're gonna say if message, which is this, has a length greater than 15. So since we have occupied the first symbol, so I'm gonna say it's greater than 15. At that point, we're gonna say lcd dot scroll display left. This is what's going to happen. Okay, so we can give a delay so that the message won't travel too fast. So I'm gonna give it a 1 second delay. Okay, so let's check this out. Okay, now if you remember in the video, in the beginning video, so whenever we send a message, the first one goes to the top, and after that the second message goes to the bottom row. Okay, so if there is a third message, again it goes to the first row. So we're gonna implement that logic now. For that purpose, we're gonna take two variables, okay, message 1 and message 2. So why two variables? Because we don't want the first message to be disappear. So we'll be using two variables and holding each of the message for each columns. Okay. So along with that, we're going to take a count. So that would be int count equals to 0. So the logic that I'm going to apply is the even and odd logic. So what I'm going to say is just count percentage of 2 is equals to 0. Okay. And here I'm gonna say count plus plus. Okay, so the logic is pretty straightforward. Like the percentage of a 2, which is a modulus, will give us the output of remainder. Okay, if we are using division, it will give us the output of the dividend, but since we are using percentage, it will give us the remainder. So whenever the count value is divisible by 2, then that means it's gonna go to the second row. And if it's not divisible by 2, then it will go to the first row. Okay, so that's the same thing we're gonna apply over here. So for that purpose, what we're gonna do, we're gonna simply say whenever the count percentage of 2 is equals to 0, we're gonna use the message, which is 2 here. Since it has to go to the second row, so we're going to say message 2 equals, what's the message that's been we are receiving? It is S. So we're going to set it to S. And the same thing, we're going to do it over here as well. We're going to make this 1. Okay. And then we have to remove this. Okay. And then we have to set the cursors as per the messages. So as you can see, LCD dot cursor. So LCD dot cursor 1, 0. So the first message will always be message 1 and it will be always in the first row, and the second message will be message 2 and it will be in the second row. Okay, this is CR, like this one represents the column and this one represents the row. So that's the reason 0th means the first row, 1 means the second row. Okay, now here we're going to change the logic as well. So if message of 1, okay, dot length is length, we need brackets, I think I missed that. So length is greater than 15, or message 2 of length is greater than 15, either one of them is greater than 15, then we're going to display, we're going to scroll left. So here the issue is that we cannot individually scroll each of the rows. Okay, so scrolling will happen for both of the rows. That's the limitation of this specific library. Okay, so here, just to see whether this logic is working or not, so for the time being, I'm gonna remove this my serial and I'm gonna use our native serial, and after that here also I'm gonna do the same. Okay, so I've already forecasting this one, like I'm using IP webcam so that you guys can see. So here's my hand, I'm resetting. I'll reset it. So let's just upload our code. So we're gonna upload our code. We're uploading, there is no errors. I think it was good, and we're done. So Let's go to the IP cam. Let's open this. So now there is no display. So what we're gonna do is that we'll try to keep it side by side. Let's see how well does it actually look. Do we have a full screen one this year? We have an option of full screen. Let's see. Oh my god, this is too. Yep, this is better. And then we're gonna go. Yep, it's working. So here we're gonna go to the Arduino code over here. So here, let's just open a serial monitor. Let's just minimize this as well. So we're gonna type message hello world and enter. I hope you can see it's pretty small, but yeah, hello world. This is some kind of whenever the wiring is not right, since we have used until and there's a backslash forward n and we're not sending it, so we're gonna get this kind of things which can be fixed on later. We're just testing the logic that we have implemented, whether the messages are coming in the affected rows or not, like the displayed rows or not. So we're gonna say this is EFS. So this should come to the second row. And here we got it. We got the message on the second row. Okay. So now let's just test it one more time. And here you got, this is a test. So this will again come on the first row. Let me just bring this a little left. Okay, here we have it. This is too big. Okay, let's do this. This is a test. Enter. Now this should change. This is a test. Now let's just increase the text size. Like I will again say this is a EFS test. See, it went to the second row and now we're scrolling. The scrolling effects get started. Okay. So now we're done with the hardware part. So let's just change it back to my serial since we're using the software serial only. So we're going to upload that code as well. Okay, we're done. Now let's start writing the code for NodeMCU. So now let's get started with the NodeMCU part. So for this, we will be requiring two libraries. So the first one would be ESP826655.h, which helps us to connect to a specific Wi-Fi and internet as well. So that would be 8266 Wi-Fi.h. And after that, we'll be requiring another library called PubSubClient, which will connect us and publish and subscribe message to the MQTT server. So that would be PubSubClient.h. Okay. So along with that, we'll be creating some variables. That would be const char pointer SSID is equals to the Wi-Fi name. So the SSID is nothing else but Wi-Fi name, and then char of star password would also be the Wi-Fi's password. Okay. So along with that, we have to define the MQTT server. So that would be const char star MQTT underscore server. Okay. So in our case, it's broker.hivemq.com. So we're using the free available MQTT server. And now we're going to define the port, and I'm going to simply say it port equals 1883. So this is the hard TCP port. And along with that, we're going to define the topic to which we are going to publish the subscribe the messages. And this point we are subscribing. The mobile app is the publisher here. So that would be EFS /IoT display, just to have some uniqueness. And here after this we're gonna take the class Wi-Fi client. This needs to be capital client, and we're gonna assign a variable to it so that we can inherit all the properties of that Wi-Fi client. And now we're gonna take the class of pub sub client, that would be this, and here we're gonna create a variable, and for that we are passing the ESP client, stating that use this specific clients, I mean this Wi-Fi clients internet to access the MQTT servers. That's what this line actually is meant. Okay, so here in the setup part we're going to do the setup. Let me remove this, and here we'll hit serial dot begin. So since we have used 1,15,200 in Arduino, we're going to use the same. Okay, so the important thing is that both of the serial communication baud rate should be same. Like for the NodeMCU, if it's 1,15,200, the same should be applied for Arduino as well, or else the data won't be transferred. I mean, the data would be transferred, but we won't be able to read it. Okay, so we're going to give a small delay of 10 milliseconds so that everything gets initialized. And after that, we're going to start Wi-Fi. That no, Wi-Fi dot mode, MODE mode, and here we're going to pass this SSID and password, comma, and that would be the password. Okay, so now we will be able to connect to the Wi-Fi. Just to see that we have reached this point, I'm gonna just say serial dot println, and we're gonna say connecting to Wi-Fi. Okay, is my audio working? Hello, yeah, it's working, just to make sure. Okay, so after that we're gonna check whether the Wi-Fi is connected or not. For that we'll be using while loop, and we're gonna take the same Wi-Fi variable, is it capital? Yeah, capital dot status. Okay, so this is a function, and we're gonna see if it's connected or not, and if it's not connected we're gonna just print some dots. So that would be WLCONNECTED. So what happens is this Wi-Fi status, whenever it gets connected to the internet, so it's gonna give us WL connected. So as long as we don't have it, that means we are not connected to the internet. So along with that, I'm just gonna print some dots just in case. I'm going to print them. I don't want to print them in the next line. I'm just going to print them so that you could have an effect. And if it escapes this while loop, and then that means we have successfully connected to the Wi-Fi connected. Okay, so we're done with this part, and now the next part would be setting up the MQTT server. So here we're gonna use this client variable, and here we're gonna set the server, that would be set server, and here we're gonna give the server name, which is MQTT server, and then we're gonna give the port. Okay, okay, now that we're done with this, so now it's time for us to set the callback client, the same variable. We're going to use this variable client dot set callback. Okay, so what is this callback? So this needs to be a function, so I'm going to write that function now. So that function, so what does it actually does? So this callback function would listen to a specific topic that we have given Okay, so once we give that specific topic, it's gonna keep on listening. That, I mean, whenever there is a data in that topic, it will be available in this callback function. Okay, so we're gonna say void callback. Okay, and after that, okay, so void callback. So here we're gonna define char. So this is gonna accept three variables. The first one would be topic. Okay, the second one would be the payload. So like, this is something not that we are not sending it, this is something that we would be receiving. Okay, and then finally we would be giving the unsigned int the length, which is not mandatory, like we are not going to use it. I mean, we will be using, but it's not like something that needs to be seen. Okay, so since the payload, as you can see, it's in the format of byte, we have to convert it in the string. So for that purpose, I'm going to take a variable string message equals, initially it's going to be empty, and now we're going to for loop it for int I equals 0, and then I less than length. We already have the length here, this one. So we're going to take this and then comma I plus plus. We're going to increment it. Okay, and after that we're going to append all of this in the message itself. So as you know, we can't append them as a characters. I mean, sorry, we can't append them as string. So we're going to append them as a character. So we're going to use the conversion here. So char of payload. So each payload has each letter. So that each letter will be now converted to char and will be attached to the string. And for that purpose, we're going to say message plus. Plus. Damn it, yeah. Oh, I'm pressing caps lock. Okay, plus. Okay, so after that, since you remember in our Arduino code, we are using until the new line, which is /n. So we're gonna add that as well. So here plus equals to /n. Okay, so after that, we're gonna just simply print the message. So here we have an option of writing serial.write as well. But since we'll be sending very short messages, so I'm not using serial.write because serial.write requires a certain set of construction and extra steps since it's not going to accept a string. So we have to convert them into a what you call unsigned int of 8-bit. So just to avoid that conversion, I'm directly using serial.print. So this is going to send the message as well. So in short, we are using the native pins of the NodeMCU itself. Okay, so here we're done. So now we're going to take this callback function and then now we're going to give it here. Okay, so now you must be wondering, like, where did we define the topic? Yes, we're going to define it now. So here what we're going to say, if we are going to check, let me remove this first. We're going to check if we are connected or not, like if the client is connected or not. So for that purpose, we're going to see client, the same variable that we have been using, client dot connected. Okay, so if the client is not connected, then we have to do something. So that would be the reconnect. So the reason why I did not subscribe to a specific topic in the setup itself, because whenever the connection will get resetted, we have to subscribe to the topic again. So for that purpose, we're gonna subscribe to a topic in this reconnect function. So we're gonna just call this function. So it won't be returning us anything, just the, I mean, it would be a void. and after that loop. So where if we don't keep the loop, it's just gonna run a single time, and after that we're done. So for that reason, we're gonna say client.loop, like continuously listen or publish the data. So that what that 42 line means. So now let's get to the reconnect part. So while the client is not connected, like the same logic here, while we are not connected, we're gonna go here. Okay, and here we're gonna say serial.println. So here I'm gonna say mqtt connecting dot. So we're gonna say like we are trying to connect. Okay, now we're gonna take the same thing. If client dot not client dot, so we're gonna use this client. So we're gonna try to connect now. So we're gonna say client dot connect and give some random ID. Doesn't really matter which one you give. I'm gonna say ESP8266 EFS IoT. You have to give something. It's not like it doesn't play a role in anywhere since we are using a free server. But if you're using some kind of paid server, this does play a role to differentiate between each user. But since we are not using any paid servers and we are using free servers, we're gonna use this. We're just gonna keep random. So here we'll say connected. So once it becomes true, that means we are connected to the MQTT server. And then we're gonna subscribe to our topic. I think I've made a spelling mistake. Oh, no, not this. So where is our subscription? Here, this one, MQTT topic. So now we're gonna subscribe to our topic. So we have subscribed. So what happens if it doesn't not connect? Since we are on the loop, like this is gonna happen anyway. Since we are in the loop, we're gonna just say like, okay, we're retrying something like this. So I'm gonna simply say serial.println, miss the dot, and then simply say retrying. So just to make sure that the NodeMCU doesn't get resetted, so we're gonna feed the watchdog timer with some yield values. That would be something like this for 5 seconds. It's not like a mandatory step, it's just a precaution. We're gonna just say delay of 1 second and then yield. Okay, so once again, this is not a mandatory step, it's just a precaution. So let's just do one thing. Let's just compile and code and see if we have any errors. That's taking a lot of time. Yep, we have an error. So where did we go wrong? Wi-Fi reconnect. So somewhere near reconnect. What do you mean? Wi-Fi serial.println. No matching function for call. What do you mean? Oh, my wrong. So sorry. So this should be Wi-Fi.begin. And this here we have to define the mode. So like we are setting a mode of station. So that would be Wi-Fi.mode. And we're gonna say Wi-Fi underscore STA station. Happens, mistake happens. Let's see. So Wi-Fi.begin actually connects the Wi-Fi and the mode sets the Wi-Fi to the station mode. Like it's gonna connect to your router. Okay. We have to define, and then we have, okay, we missed the semicolon here. Is there anything else? We have a loop. Okay, let's compile it one more time. I think it is working. Yep, now it's done. Okay. So I have already uploaded the code and I given the server name, I mean the SSID and password of the Wi-Fi. So we are connected. So I'm just gonna reset the Wi-Fi so that you guys can see. Okay, let's reset it once. Got some gibberish. It's connecting. Wi-Fi connected, MQTT is connecting, and most probably it will be connected as well. So for the testing purpose, what we're going to do is that we're going to use the MQTT WebSocket client itself. Okay. So here we're going to define the host, which would be broker.hivemq.com. Here, the port will be left as 1888.884. And here some last topic, we're going to just give some random topic since we don't have it. I'm going to say testing, and here we're going to connect. Okay, so we are connected. So what is the topic that we have defined? That is EFS iOS display, not iOS, sorry, IoT display. So the same topic, we're going to paste it over here. So as you can see, no, I clicked on S. So as you can see, I've already defined it over here. I mean the IP webcam. So I'm just going to reset it. Okay, so let's keep them beside each other. And let's use full screen. Yep, that's good. So we're gonna just publish a message. We're gonna say hello world. Click on publish. Hello world. I hope you can see it, like it's very. Let me just expand this. Yeah, you can see, right? Hello world. I'm gonna just send another message. Hello world. We're gonna just add EFS to this and we're gonna publish this. It should come to the bottom, and you can see it has come to the bottom. Let me just expand this to you. We'll be getting this kind of some gibberish characters since we are using a free server. So we will be having this kind of gibberish character. So don't really mind that. And now let's test the scrolling. So here I'm going to add one more variable, testing. So this will force it to scroll. See, hello world, EFS, testing. So that proves that Arduino logic and as well as a NodeMCU logic, everything is working perfectly. So the only step that's left for us to do is to build an app which does what this MQTT, I mean this MQTT WebSocket client is doing. So let's get into that part. Okay, now let's get into the mobile section. So here I have already run the emulator so that our time would be saved. So we would be requiring two packages. So the first one is the MQTT client and the HTTP packages. You already know what MQTT client is for. It's for connecting to the MQTT server, and the HTTP client, we have a specific purpose for that, and I'll be revealing it in later part of the video. Okay, so here in the main.dart file, we have already done these sampling things already, like the map creation, the stateless widget creation and all. And we in the home section we have kept a container, and also we have created an IoT display dart file. So this is the section, this is the file where we are gonna code everything. So let's create a stateless widget, and I'm gonna call it IoT display. Oh no, my bad. So I think we need a stateful widget since we're going to use set state. So let's write IoT display Okay, and we have to import the package, material package. Let's see if we're gonna get it now. So you're gonna get a icon over here. We're just gonna click and we're just gonna go for this. Okay, so the material package, and then now what we're gonna do, we're gonna import this in our main.file. So most probably we're gonna get an error. Oh no, it's already imported. So since we haven't kept any scaffold or anything, so we're gonna get some errors like this. So now what we're gonna do, we're gonna remove this and we're gonna keep scaffold. Okay, in the scaffold we're gonna set the resize to bottom avoid to false. So this is so that whenever the keyboard comes up, our app doesn't resize it to that specific side. It maintains its actual size. So whenever if we keep it as true, it's gonna resize. If we keep it as false, it's not going to resize. Okay. Then the app bar, we'll be requiring the app bar. So app bar. So here the title will be text IoT display. Okay, I use a capital I. Okay, and after that we're gonna do some styling to this. So the style, so that were not here, sorry, here we're gonna do some styling. So that will be style, text style. So we missed a comma. So here it would be font weight, and the font weight will be bold. Okay, so after that we'll be requiring color. So since we're going to use the background as black, if you remember the video which we seen at the beginning, the app has a background of black, so the font will be white. Colors dot white. Okay, and after that we're gonna give the font size. Since it's an app bar, we're gonna give it a bit of bigger font. So I'm gonna say 23. You can just adjust it however you want. Okay, so now you can see we got an empty white page. Since the font is white, you won't be able to see the font. So now we're gonna declare the body. So we're gonna call a container. So in the container, we'll be setting a padding of 15, edge insets dot all, that makes 15, and after that we're gonna set the width to maximum double dot infinity, I guess, so that it can occupy whatever the width it has. And then we're gonna go for the decoration, box decoration. Actually it's not required since we won't be setting any kind of edges to it, so I'm just gonna simply say color, and then I'm gonna give a color. So I already have fixed those colors. I got the codes. I'm just gonna use those codes directly, copy paste them. So this is the code for the pure black. It's not like a pure black, it's like a grayish black. Okay, so along with that, I think, yeah, the app bar color needs to be fixed as well. So let's go here to the app bar. We're gonna say background color, and we're gonna apply the same color here as well. And since we want it to be at the center, we're gonna make the center title as true. Text element will not work. So we got the IoT display. Okay, so we're done with the app bar part. So we're going to close this, and now we're going to go to the container. So as you can remember in the design, let me just, so let me pull out the design screenshot. So remember, we have created this website, so I'm using it to share files between my mobile and my laptop. So let's download this image. Let's go there, open this up, and this is the design that we're trying to achieve. So we will be requiring two boxes over here, a message label and a text box and a small message, last sent message label, and finally the button. So this is the design we're trying to achieve. So we have already were able to do this. So the next thing would be, so let's create a column child. So since all of them needs to be placed somewhere, so we're going to create a column, and in that we're going to say main axis alignment dot space between. So what I'm trying to do is we are gonna, oh, there are two. So we are trying to keep all of them under one part, and this button, since we're trying to push it down, so that's the reason we're keeping this button in a completely different thing. Okay, like all of these elements will be in a single container or a row or anything like that, and this will be in a different container, and both of them will be in this column. Okay, so let's do one thing. Let's create another children. Okay, inside that, let's create the button first. Or no, we have to create this first. I'll just show you, like column children column, and in that I'm gonna say children. We got this, and here we're gonna create the button. So for that, I'm gonna close this, and here I'm gonna take the elevated button. The on pressed will be empty. The child will be text. So what would be the text be? Obviously the text would be send, and in this we're gonna keep some style, text style, and then the color would be white. So colors dot white, and I'm gonna give it a font size of 20. I mean, it's not necessary that you give a font size, it's gonna take the system's default font size, but just in case I'm giving it. So you can see, right, since we're using the space between, it has completely went down. So now let's style it a bit more. So let's keep this over here, and then we're gonna use the style. So let's see the elevated button. We're not going to use the elevated button. Like, so this commands, like we are trying to access the internal style of it. So we're going to say style from. Okay, so now we're going to set the background color, background color to a specific color that I have chosen already. So we're going to copy paste it. And then we're going to say minimum size. So we have to give width and height. So but I'm gonna just say to occupy the entire width. So I'm gonna say double dot infinity, but the height I'm gonna give it a value. So I'll be saying it would be around 50. Okay, let's see. So see, you got it. So I don't want this border radius to be this much. So I'm gonna set the border radius as well. So here border radius will not come directly. So we're gonna use shape, rounded rectangular border, enter, border radius, border radius dot circular dot 10, not dot, just 10. So we got a flat button. So when we're done with the button part, so we'll be working later on the logic. So now let's get into this part. So now we're gonna go to the children, okay, and create our two stuffs like this. There's two buttons. So for that purpose, let's create a row since they are side by side. In this, we're gonna give children, and we'll be keeping the main axis alignment as the max size. Main axis size dot max. Oh, it's actually not main axis alignment, it's main axis size. Okay, so after that main axis alignment, we're gonna say space between. You can even say space evenly, doesn't really matter. So now in the children, we're gonna create a common widget since both of them, you know, kind of look similar, only the changes in the text and the way the icons. So we're gonna make a common component, and I'm gonna call it connect block. So let's create a stateless widget here. Connect block. Let's remove this. So here we're gonna create this. So this will be accepting some kind of parameters. Let's just define those parameters first. Okay, so here let's say it accepts three parameters. The first one is the status, like whether it's on or off. Okay, like is it connected to internet or is it not connected to the internet? That's kind of scenarios. String, the name, like is it Wi-Fi or is it internet? And then finally we have the icon data so that we can pass the icon as well. So I'm gonna say icon here. Okay, then we're gonna create the connect block, and we're gonna give them as the name parameter. This dot status comma this dot name comma this dot icon. Since they are optional parameters, so we have to give some kind of value. So I'm gonna give them some default values. So the name will always be empty, and here the icon will be some kind of icon. Icons dot, let's just say ABC. Okay, or I'm gonna say here we're gonna pass a container. So since we'll be using it without defining any width, so I'm gonna wrap this with an expander so that it takes whatever available space it has. Okay, so now we're gonna give it a margin, edge, insets dot only. Now let's not give it margin. Let's see how it actually looks. After that, let's give the margin. Decoration. So we're gonna see the box decoration. Since we have to set the border radius. So border radius. So border radius. Border radius dot circular. We're gonna give it a 10. And after that, we're gonna define the color. So it would be similar to this color. So I'm just gonna copy paste it from here. What is that? Yeah, here. Okay, so here we're gonna write a small logic on depending on status. As you know, when the status is true, that means we are connected, so we can show the blue color. But when the status is false, we have to show the red color. So I'm gonna say colors dot red. What's wrong? Oh, this needs to be capital. Okay, so we're pretty much done. Let's see what happened. Why is it failing? Where are we failing? Connect block. Oh, okay, it's not coming. Let's refresh it. Why is it not coming? Did I call it? Yep, I did. Okay, there is no data, I guess. Oh, we need to put some kind of data since we're not defining height. Okay, let's give it some data. So I'm gonna say child. We're gonna use the list style. Since we are using expander, so it's not gonna cause us any issue if it's even wrapped in the row. So we're gonna use list style, and here in the leading, we're gonna define the icon, and that would be icon. We're gonna give it a size. So we're gonna give it a size of 40. So yeah, it needs an icon first. So for that purpose, we're gonna use the icon here, icon. So that went away, and after that we're gonna keep the color as white. Okay, so after the leading one, we will be requiring the title. The title would be the name. So we're gonna say text. We're gonna pass the name to it, and after that we're gonna define a style. We're gonna make it text style, and then we're gonna set the colors dot white, and we're gonna set the font size to 80. So as you can see, we got something with the icon ABC. Now we're gonna do the same for subtitle. So it's gonna say text. Here we're gonna follow a same logic of status. Here, if it's true, then the text would be connected. And if it's false, it's gonna be disconnected. Okay, so after that we're gonna define the style for this. So this is pretty much the same style. Only thing is that we won't be using the font size. So we're gonna remove the font size. So you can see disconnected. So we're done with this part. So let's just give the names to it. So the first one will be internet, INTERTRNET, internet. So since they are naming parameters, we have to define the name internet. So status, well, status initially will be false, and then the icon will be icons dot Wi-Fi. So we have an option of keeping another icon as well. So we're going to do once we apply the logic. So now same, I'm going to call it MQTT. Okay, the status will be false. The icons will be icons dot storage, and if we press this, we need some gap in between this. So let's do one thing. we're gonna add a size box of width 10. This should be, yep, we got the size, we got the difference. So if I just make it as true, you'll be able to see what happens. See, it's connected. So we're done with this part. So the next part would be adding this text boxes. So now it's time to make the text box. So let's go here. So after this row, let's close this. Let's give it a small sized box so that we could have a margin of height, say 15. And then we have to create a label, right? So for that purpose, text, I'm gonna call it message, style, text style, and then we're gonna say font weight dot bold, so that the text would look a bolder. Color would be white, and then the font size would be much bigger, so it's 30. Now we're gonna save. You can see we got it over here, but this is towards the left center, so we have to make it such a way that it always stays at the left. So in the column we can use the cross alignment dot start, and the message would come to the left. But I think this needs some more gaps. I'm going to keep message a height of 25 to the size box. So after that, I'm going to use the same sized box, and this time I'm going to decrease the height a bit lesser, and then I'm going to define the text field, not text form field, just the text field, with the max lines of 5, and along with that max length of just 100 words, since we are using a free MQTT server. So I'm just placing some limits. Then we're gonna set the text color. Why can't I see this? Style, sorry, text style. Okay, for that, and this prompting is blocking everything. So in this, we're gonna set the color to colors dot white, and after that we're gonna keep a decoration, and that would be input decoration, so that we can decorate the text box itself. As you can see, it's looking pretty bland right now, so we're gonna use the input decoration, decorate the text box itself. So I'm gonna give a hint message. I'm gonna just say enter your message, and after that would be a border. I like borders, so that would be outline border, input border, and here I'm gonna give a border radius dot circular of 10. Okay, let's see how it is right now. See, it looks much better right now. Okay, so we're done with this as well. So let's just close the text field, and if you remember, we are actually capturing the last sent message over here, so let's create that. So we're going to give another sized box. So this time it would be around a bit more. I'm just gonna give it back to 25, and here I will simply write text last sent We're gonna soon write the logic. In that you will be seeing like how the message gets appends over there. Okay, so style, text style, color, colors dot white, and then a font size of 18. I should do it. Let's see. See, we got it. Okay. So now let's just implement a small logic, and that would be like getting the container, like the text box data, and appending over to the last sent. Okay. So for that, let's create a controller, and that would be the text editing controller. And I'm gonna call it just controller itself. And that would be text editing controller. Let's say then we're gonna define message equals empty, since we have to hold the message. Okay. And then now we're gonna assign this controller to the text field. So we're gonna use the keyword controller, and then we're gonna pass the controller. So this is the controller keyword, and this is the controller. Let's just call it message controller just in case. So this would be here, message controller. Okay. So now what we can do is that we have to append whatever message we are getting to the last sent. So for that, it's pretty straightforward. All you gotta do is just place over the message. That's it. It's gonna get appended. Okay. So after that, we have to write the send logic. So how we're gonna write the send logic? So whenever the user clicks on send, only at that point, extract the text, whatever present in the text editor, and then pass it to the MQTT. So in this case, we're gonna pass the whatever text present in the controller to the message. So let's write a set state. So we'll be requiring set states here, since we have to display the message. Oh, no, it doesn't work. The auto format key is different here. Okay, now man, we're gonna simply say message is equals to message controller dot text, and this should just do the trick. If I just say hello and go down and click on send, you can see here, right? Hello. Okay. And after that, we have to make sure that we clear the controller so that we can see the new message. I mean, in general, like if we don't do that, you can see, right, the hello is still there. So now I'm gonna send hello world. Oh, sorry, not here. Here I'm gonna just give some space and send hello world. Now you will see that this would disappear. Okay, this needs to disappear. Only at that point, user would understand that yes, the message has been sent. Okay, so we're done with the UI part. Now let's add the main PubSub client library. For connecting with the PubSub client, we'll be requiring a library called MQTT client. So you just need to paste it in your PubSub YAML file and then just do the pub get. So it's gonna get installed. So now let's just go to the IoT display. So here the first step would be declaring a variable client. Okay, is equals to MQTT server client. Okay, so the client identifier can be anything. I'm just gonna say ESP for the time being, and then the server, you all know what server is. That's broker dot imq.com. Okay, so after that we have to declare a function of future that returns something of integer type, and that would be set up MQTT client. Okay, so now we're gonna write the code that connects us to the MQTT client. Okay, so the first one will be client dot. So we're gonna stop the logging because we don't want a lot of data on it on our screens. So we're gonna stop that, and then now we're gonna use the protocol. So we're gonna use version v3.1.1 since this is the latest, and then we're gonna define the alive time. So that would be 20 seconds. This one takes seconds. And after that, we're gonna set the connection timeout. Like if it doesn't connect within this certain period of times, reconnect after 2 seconds. I mean, try to reconnect after 2 seconds. Then we're gonna define what we need to do on connected. So this one comes as a function. So we're gonna define a function. That's okay. I keep forgetting this is not JavaScript. Client dot connected equals, then enter. Here we're gonna print connected and the same for disconnected. Dot on disconnected, we're gonna say disconnected as well. Okay, so we're getting an error because we have to return a future. Let's just return something here. So this will be an error because we are not using a await anyway. So once we use an await, this is gonna go off. Now let's try to connect. So we're gonna say final. We're gonna say connect messenger something is equals to MQTT connect message. Now here we have to define some kind of sort of other parameters to make the connection. So the first one will be an identifier, which is not required to be the same as the above, since we are using a free server. So I'm just gonna say ESPEFS. Okay, it just needs to be unique. But if you're using a paid server which has number of users, it's gonna work. And then we're gonna set a will topic. So this will trigger whenever the connection gets established to the server. So I'm gonna just simply say will topic. Oh, so all belongs to the one section. So yep. And then we're gonna say with will message, like what are we going to send. So I'm gonna set it as will message only. And after that, we have start clean, like close all the old sessions and start as a new session. And finally, why am I getting the same class? Yep. And then finally with QoS, like what is the quality of service. So I'm just gonna say MQTT dot at least once, and we're done. So after this, we're gonna try to client dot connection message. Like, I mean, we are trying to establish a connection to the MQTT server with all these parameters. So we're gonna just simply pass conmess. Okay, and after that, we are now gonna define the connection. Now we have passed the parameters, and now we have to connect. So for that, I'm gonna keep the entire code and try catch block. In this case, a try on block. So here we're gonna say no connection exception, like if we are unable to connect, so catch e the error and then print something. So in the try, what we're gonna do, we're gonna simply say await, okay, client dot, I think I haven't given a sync here, okay, client dot connect. So if you have usernames or anything, you have to define the usernames in this, but since we don't, we can skip that step as well. And here we're gonna say no connect exception. We're gonna say simply print unable to connect. If you want, you can even print the errors, but I'm not gonna do that. Like if you just print the E, you'll be seeing the reason why it's not connecting. So now I'm gonna say client dot disconnect. So like it's not connecting, so just disconnect it. And after that, we're gonna return 1. Okay, so this is one exception. So along with that, like if nothing like this happens, then at the final step, we have to check whether the connection, like we're not getting any error, then we have to check whether the connection is established or not. For that purpose, what we're going to do, if it's not an important step, but if we do that, we can kind of whenever we can understand whether the server, I mean our app is connected to the MQTT server or not. Line dot connection status of dot state is equals to MQTT connection state dot connected. If this happens, yes, we are connected. So I'm gonna just simply say return 0, and here we're gonna print hive MQ connected. Okay, and in the else block, if it's not, we can just simply say not connected and return a 1. Okay, and finally, oh cheat hurts. And finally, if nothing of this, most probably like there could be anything. So after a certain amount of time, we need to disconnect it manually. So we're gonna say client dot disconnect. Just a second. Let me remove this. And this. Okay. So whenever we are closing something, we have to make sure that our client is disconnected, or else it's continuously gonna try to reconnect. So we're gonna disconnect. Okay, so we're done with most of the steps. So we're done establishing a connection. So you must be wondering, like, where is the point where we send the topic? That would be in the MQTT button part here. Okay, we will be writing a separate logic for that. So in this, since we have to initialize it in the beginning itself, so we would be now requiring init state. Okay, so the init state, what we're going to do, so simple, we're gonna put this in a, since we can't keep an async block to the init state, so what we're gonna do, we're gonna create a function called initialize. Okay, async await, and then initialize async, and then in this we're gonna say int MQTT equals await setup MQTT client. So we're calling this. So now to change the status, so we're gonna define two Boolean variables. So the first one will be bool MQTT, that's false, comma inter internet equals false, and after that we're gonna say set state MQTT equals, let's not call it MQTT, there are two variables, we may just get an error. Let's call it MQTT server. MQTT is equals to MQTT server is equals to MQTT whether it's 0. If it is 0, MQTT is true, that means we are connected. If it is not, then we are not connected. So now I'm gonna pass this variable to the, where is that connect block? Oh yeah, we have closed it to this one, this. Okay, now let's just try whether it is working or not. Oh yeah, we forgot one more step. We have to call this initialize and the sync and the init state. So we're gonna just, after super init state, we're just gonna call the initialize. So we should be able to connect. See, we are connected to the HiveMQ. Okay. Now we're gonna create a small function that will help us sending the message to the MQTT. So I'm gonna call it void message sender. Okay. Since we need an await, so we're gonna make this an async function, and this would be accepting one parameter, that is a message. Okay, and now in the final messenger or message MQTT client payload builder. Okay, and in that we'll be say messenger dot add string msg. Okay, so now we're adding the message, and now we're going to publish it. Client dot publish message. So you can see the topics which we need to define. So our topic is EFS /IoT capital D display. So if you remember, this is the same topic that we have used in our NodeMCU code as well. So here we're gonna define the quality of service, and that would be at least once. And then finally the data, which is nothing but the messenger dot payload, and this could be null, so we're gonna keep a null operator. And then finally we're gonna await whether we have send the data, like await, like we cannot send multiple set of data at a time, so we are making sure that the publisher sleeps for certain amount of time. So for that purpose we are using MQTT utilities dot async sleep, and we are going to give the time to 20 seconds. Well, let's decrease it a bit. 20 seconds is a lot, so I'm just going to say 10 seconds. Okay, so now we're going to just simply send this message, use this message sender to send the messages. So you can just simply say, or else there's one more thing that we need to apply. So we have to make sure that we are connected to the MQTT client. So for that purpose, let's write another function here, and that would be void checker. I'm gonna call it checker. So here I'm gonna write a try catch block, catch errors. So when there is error, there is no need to do anything, just says print what are those errors. This is not a mandatory step. I'm just making sure that we are connected to the MQTT server before sending the message. If client dot connection, oh, we can use that same thing. Yeah, this line. So let's go. We can use this line. Connection state. Let's go down, and here we're gonna say message sender. So since this is accepting a message, so we have to make sure that we are also sending a message. Okay, and then the else block, what we're gonna do, we're gonna say final result. So like if we are not connected, then we're gonna try to reconnect. So here let's make it async, and here is equals to await and set up MQTT client, boom, and if result is equals to 0, okay, if the result, like the we are able to successfully connect to the MQTT server, then we're gonna call this. Else, not here, here, else we're gonna print unable to send message. So this is just an extra precaution to make sure that our message reaches the MQTT server. So here we're gonna take this checker, and then where is the logic button? Yeah, here we're gonna place it over here, and we're gonna use message or controller dot text to send the message. Okay, let's just rerun the app. So as you can see, the MQTT server just popped up and came back. So now let's just go to the client, MQTT WebSocket client. So here let's connect it, broker.imq.com, last will topic something. Again, click on connect. Okay, we have to give some proper topic. Broker broker.imq.com. Okay, texting, let's connect. Yes, we are connected. We have to make sure that we subscribe to a topic so that we can see the message. So what's the topic? So let me copy paste it from the code. So we placed it in the message sender, right? Here, this is our topic. So now I'm going to do this and click on subscribe. So this is subscribe. Now I'm going to minimize this. That is already minimized. I'm going to just place it beside each other. So here I'm going to say hello world and click on send. So you get a message. Let's expand this. We did not get the message. Let's check what's happening. I mean, we were able to publish something. Let's see. Message controller dot text. This is what we're getting, right? So what? The text could create a problem. So let's use Oh yeah, we're clearing it. So no way we're gonna get that. Okay. I think it should be on the top here. Not clear. Until this doesn't happen, we should not clear the message. So that's the reason we got the empty response. So now let's do the same. Boom. It's already subscribed this time. Let's say hello world. Click on send. We got the hello world. So this is working as expected. So now let's add the internet checker. So for adding the internet checker, we have a package called internet connection checker plus package. We have a lot of packages, but I'm not going to use this package. So I'm going to write a small logic so that we are able to check the internet using our own logic. So the rule is pretty simple. Like the logic is pretty simple. So even in the internet connection package, what happens is that it hits a certain different set of websites and APIs, and once it get a correct response from all of those, only at that point it says that you are connected to the internet. Okay, so we're going to use the same logic, but instead of hitting multiple different sites, we're going to just hit Google, which is always active. So if you want, you can use the uh, uh, network checker, not yeah, internet checker connection flag package, but I will be using the HTTP package to do that. So let's say future int, and here I'm gonna say check internet, and after that I'm gonna simply write a try catch block so that we can catch the errors. So in the try, I'm gonna say var URL is equals to URI dot HTTPS, since it would be HTTPS. So and type google.com. Okay, and after that var response. So we're expecting a response. Await, forgot the async. Await http dot get URL. Okay, and after that, the main thing, we're going to check if the response dot status code is equals to 200 or not. If it is, then return 0, else return 1. So this was the logic. Same goes for the catch block. So we're going to say return 1. Now we're going to use this in the same initialize stuff. So let's apply the same logic here as well. So we're going to call it internet. And here we have another internet. Now I'm defining same names again. I'm just going to call it web. Internet internet equals to web dot sorry, internet equals to web double equals to 0. Okay, so if it is true, then we are connected to the internet. If it is not, we are not connected to the internet. But there's a problem. We have to make sure that this runs again and again and again, since we could lose internet at any moment. So I'm gonna write a small period function, like a periodic, a timer, which hits this API for every 5 seconds. So for that, let's go into the init state. So below init state, we're gonna declare a variable. So before that, we have to declare the type of this variable, which would be late. So since this is gonna get lately inside, and the type of the variable is timer, and I'm gonna call this timer. So I think I have to import a package. Yep. Okay. So here what I'm gonna say timer equals to. The reason why I have assigned a variable, because on the close of this we have to dispose the timer. So for that purpose I have assigned a variable to. So I'm gonna say duration seconds, and that would be 10, and then finally we have callback. So in this callback is what we're gonna take the data, like whatever we write in the callback executes after this certain period is passed. So here I'm gonna check. So we've defined a function, right? So we call it check internet, right? So here we are going to go, what is that? Yeah, check internet dot then. So here I'm gonna define a function wall, enter. Here we will be setting the state, and that would be set state. So here internet will be val is equals to 0. So now what we're going for the MQTT server, that since we are checking the internet, let's check whether we are connected to the MQTT server or not. For that we can simply use this logic over here. What I'm going to say client.mqtt dot connected, then MQTT is true. So now this is gonna check for every 5 seconds if, like, sorry, for every 10 seconds, like if we have an internet, if we are connected to the MQTT server or not. If it isn't, then like for that 5 seconds we are not able to connect. After that again it's gonna try to reconnect. Okay, so I think we're done with most of the part. Like we're done with everything actually. So we have defined this texturing control, so we have defined that. Let's just check whether it's working or not. So I'm gonna just do this. So we're now connected. So I'm gonna switch off all the internets, like the Wi-Fi, and then we have the mobile. So I'm gonna turn them off. So we're immediately disconnected to the MQTT. So now we will be disconnected to the internet after few seconds. Wait, I'm not passing the parameter. Oh, sorry guys, I'm not passing the parameter. Let me pass the parameter internet. So let's redo this. So now if I switch on, after a few seconds this would change to connected. See? Yep. So with this we are done with the entire project. Now let's just check whether this is working or not. So here we have the device. Let's just minimize this. Okay, and here we have the connection setup through which I'm streaming through the IP webcam. So what we're gonna do is that we're gonna send the message. I'm gonna type hello world, hope it's visible. Just gonna minimize this as well. Yep. And then I'm gonna click on send. So it should display. Yep. As you can see, if you're not able to see it, So let's just check the other one as well. Hello world test, and then click on send. So this should appear. Yeah, you can see, right? Since we have added some spaces, so the scrolling effect has started. Okay, so I think, yep, we're done with our project number 3 as well. So as usual, I'm gonna leave a GitHub link in the comment section, and since this is just a single file, I'm not gonna keep the entire Flutter structure inside it. I'm gonna only keep this specific code. Okay, and also I'm gonna define in the README file, I'm gonna specify the versions which I have used over here. Okay, and one more thing, guys, just make sure that you kind of take the pull from my Flutter repos every single time, because if at any point if I feel like I can upgrade this a bit more or add any kind of new feature, I'll be doing that in my old applications as well. So make sure that every time you use my application, just take a pull so that you could have the latest features. So yeah, thank you for watching, and I'll make sure to come back with a new project in the next episode. Thank you for watching. Bye.